So question 9 part A is asking us to write down the predicted population at the end of the second year when we start off with a population of 130,000 with an increase of 2%. So all we're going to do is take 130,000 and multiply by 1.02 for a 2% increase, which gives us 132600 as requested. Part B is asking us to write down the common ratio. Well, the common ratio is 1.02 because that's what we multiply by each year. And then part C is asking us to find the year in which the population reaches 260,000. So basically when it's doubled. So we're looking at the yearly population here, not the total population. So we don't want a sum. What we want is the nth term. And the nth term, if you remember, is given by AR to the n minus 1. So we want 130,000 multiplied by 1.02 to the n minus 1. And we want this to be bigger than 260,000. So the first thing I'm going to do is get rid of this 130,000, divide both sides. So 1.02 to the n minus 1 is bigger than 2. Now I need to take logs of both sides, logs to the base 10 or logs to the base, or logs to the base 10 in this question. So the log of 1.02 to the n minus 1 is bigger than the log of 2. I'm assuming these are logs to the base 10 without the numbers written down. Use your log law and bring the power down in front. So n minus 1 multiplied by the log of log of 1.02 is bigger than the log of 2. So, bigger than sign. And then if I divide both sides by log 1.02, I get n minus 1 is bigger than log 2 divided by log 1.02. And then finally I need to get the n in its own, so add 1 to both sides. So n is bigger than log 2 over log 1.02 plus 1, as required. And finally part D asks us to find the value of n. So n must be bigger than, if all of this goes into your calculator, what you end up with is 36.0027. Now it must be bigger than 36.0027, so our value of n must actually be 37. You're always going to round up here, never round down.